So this video is going to go over the intermediate value theorem and a couple other special characteristics of polynomials. So the intermediate value theorem, because math is so creative, tells you there's an intermediate or a value in between two things. So let's read the verbiage first and then kind of break it down. So we have a and b that are real numbers, and a is smaller than b. They are my x values. When I plug a into the function or the polynomial f, and I plug b into the polynomial f, I get different values. So f of a and f of b cannot be the same. Then on the interval from a to b, these are x values. F, the polynomial, takes on every value from f of a to f of b. So what that's saying is, let's make up some pretend numbers. So if my interval goes from 1 to 3, and f of 1 equaled 2, but f of 3 equaled -8, then I know that my polynomial, because it's continuous, polynomials are continuous, because of these statements right here, I know that my polynomial between 1 and 3 takes in every value from 2 to -8. So I touch 1, 0, -1, -2, -3, and all the decimals in between, not just the integers. So this is super helpful when trying to find the zeros of my function. So let's look at what this says. So x equals a, f of a is positive. X equals b, and then f of b is negative. That means you must have had at least one real zero between those two values. So let me draw it real quick. So here's my graph, and I plug in some a value. And my graph is up here, it's positive. And then over here is b, and I plug it into my function f, my polynomial, and I'm negative. Well, that means I don't know how this polynomial moves, but somewhere between these two things, I must have crossed the x-axis to find a 0. The same thing works if f equals a and then f of a is negative, and x equals b and f of b is now positive. The key is you must go from negative to positive or positive to negative to ensure that you cross that x-axis and you had a polynomial. So let's look at the example below. So it says, given this function, we make a table. Using the table, what assumptions or conclusions can you make about the polynomial f of x? Well, right here, do you see how I go from negative to positive? That means I know somewhere between -1 and 0, somewhere in this interval, there must be a 0. And in the upcoming sections, we're going to learn how to find those zeros, but what we know right now is that there must be a 0 somewhere between -1 and x equals -1 and x equals 0. This right here, how to use some information like this to narrow down where my 0 might be. And then again, in the upcoming sections, we will find out how to find those particular zeros. Okay, a couple vocab words that we need to talk about, and you've learned about increasing and decreasing, but let's look a little bit closer. So this first one says when a graph is increasing and positive, it is concave up. So increasing, concave up, decreasing, concave down. Point of inflection is the point where the concavity changes on the graph. So let me draw a quick picture. So if I draw a little polynomial, so I'm going to do this, concave up is right here. This piece in here, I'm concave up. Sorry, I shouldn't have done too far over. So in there, I'm concave up, and in here, I'm concave down. And the place where I change in between is called the point of inflection. A couple quick counting principles. A polynomial has a degree that highest power, then it has at most, n minus 1 local extrema, which we call max and min. The polynomial has a degree n, then it has, and n is greater than 2, then it has at most n minus 2 points of inflection. has an odd degree, and n is greater than 2, it has at least one point of inflection. And these are vocab words. Point of inflection is something you use a lot in calculus. So the biggest takeaway from this video is not maybe this section.